friends to Maths Practice. Today we are going to start the chapter Polynomials. In the first part we are going to see the key concepts and the examples based on that, and in the second part we will see some extra practice examples. First we will define a polynomial. A polynomial is a mathematical expression which consists of one or more terms, each of which consists of a constant multiplied by one or more variables raised to a non-negative integral power. For example, 3x square plus 2x plus 5. Polynomials can be classified according to three criteria. Firstly, based on the number of variables. If the polynomial has only one variable, it is called univariate. For example, x minus 5, where only x is the variable. Bivariate means it has two variables, for example 3x minus 6y plus 9, and multivariate. Now according to degree, if the polynomial is just a constant, for example 3, it is said to be of degree 0. Why? Because anything raised to 0, say x raised to 0 is 1. So any constant is a polynomial of degree 0. Linear means degree 1. For example 2x plus 5, where x is raised to the power 1. Quadratic polynomial is of degree 2. For example root 3x square plus 3x minus 8. Here x, the maximum power of x is 2. So it is a quadratic polynomial of degree 2. Cubic and so on of any degree n. Now according to the number of terms, it can be classified as monomial, means just one term, say 5x. Binomial means it has two terms, say 5x plus 3. It can be trinomial and so on. Let us define some terms. If px is a polynomial in variable x and if k is any real number, then the value obtained by replacing x by k in px is called the value of px at x is equal to k and is denoted by p of k. That means, for example, if I have px is equal to 3x square minus 5x minus 8. If I replace x by 1, means if I put the value of x as 1 in the polynomial, I get p of 1, which is equal to minus 10. Now what is a zero of a polynomial? A real number k is said to be a zero of the polynomial px if p of k is 0. Means when I put the value of x as k, the value of the polynomial is 0. For example, in the above polynomial 3x square minus 5x minus 8. If I put x is equal to minus 1, I get p of minus 1 as 0. So I can say minus 1 is a zero of the polynomial. Sometimes it is also called root of the polynomial. Remember two things. 0 is always called the zero polynomial and its degree is not defined. And a polynomial of degree n can have at most n zeros. Means if you have a polynomial of degree 2, it can have at most 2 zeros. Now, how to find the zero of a linear polynomial? Means the polynomial of degree 1. For example, if you have a linear polynomial ax plus b, where a is not equal to 0, the graph of y is equal to ax plus b is a straight line, which intersects the x-axis at exactly one point, which is minus b by a 0. Now why does this happen? We have just now seen that the zero of a polynomial is the value at which the value of the polynomial is 0. Means when you put y is equal to 0 in y is equal to ax plus b and make x as a subject of formula, you get x is equal to minus b by a. So at the point x is equal to minus b by a, we have y0, the value of polynomial 0. So we can say that the linear polynomial will have one 0 which will be at x is equal to minus b by a. Let us take an example. For example, if y is equal to 2x plus 4, we can see that the graph will be a straight line which passes through many points, say 0, 4 and 1, 6. Now here we have, if you compare with y is equal to ax plus b, we have a is equal to 3, b is equal to 2. So the 0 will be at the point minus b by a, which is minus 2, 0. So at the point -2, 0, the x coordinate is -2. So we can say -2 is the zero of this linear polynomial. Now the zero of a quadratic polynomial. For any quadratic polynomial ax square plus bx plus c a not equal to 0, the graph will have one of the two shapes of a parabola, either open upwards for a greater than 0 or open downwards for a less than 0. For example, the graph of y is equal to x square minus 4x minus 5. Here a is equal to 1 means a greater than 0. So it will be a parabola open upwards, and the zeros will be the points at which it intersects the x-axis. Always remember, the point at which the graph intersects the x-axis will give you the zeros. A quadratic polynomial is a polynomial of degree 2. So it will have at most 2 zeros. The zeros of a quadratic polynomial will be the x coordinates of the points where the parabola intersects the x-axis. Let us see some graphs of a quadratic equation ax square plus bx plus c. Now in the first graph you can see that the parabola is facing upwards and it is intersecting the x-axis at 2 points, so it has 2 zeros. In the second one, again, since it is the parabola facing upwards, the value of a is greater than 0, but it is intersecting the x-axis at only 1 point, so it has only 1 zero. In the third one, it does not intersect the x-axis, so it has no zeros. This shows that a polynomial of degree 2 can have at most 2 zeros. Similarly, in the next three graphs, you have a less than 0. So the parabola is facing downwards. If it intersects at 2 points, it has 2 zeros. If it intersects the x-axis at 1 point, it will have 1 zero. And if it does not intersect the x-axis, it will have no zeros. These are the graphs of some polynomials. You can see that the number of points at which it intersects the x-axis will give you the number of zeros. If it intersects the x-axis at 3 points, the number of zeros are 3, and similarly others. Now an important concept, the relationship between zeros and coefficients of a polynomial. Now if it is a linear polynomial, for example ax plus b, we know that the zero is that x is equal to minus b by a. It has only one zero, which is at minus b by a. Now if it is a quadratic polynomial, we know it can have two zeros. If alpha and beta are the zeros or roots of the quadratic polynomial ax square plus bx plus c, where a not equal to 0, then the sum of zeros means alpha plus beta is given by minus b by a, which is minus of coefficient of x divided by coefficient of x square. The product of zeros alpha into beta is given by c by a, which is the constant term divided by coefficient of x square. Cubic polynomial. Suppose if you have a cubic polynomial, it can have three roots alpha, beta and gamma. The sum of the zeros alpha plus beta plus gamma is given by minus b by a. The product of zeros is given by alpha into beta into gamma, which is minus d by a. And you can also have the sum of product of zeros taken two at a time, which means alpha beta plus beta gamma plus gamma alpha is equal to c by a, or coefficient of x upon coefficient of x cube. We will be using these concepts in the next examples. Now another important thing is, how can you form a polynomial given its zeros? If we want to form a quadratic polynomial, that is a polynomial of degree 2, when its zeros are alpha and beta, then the polynomial can be expressed as some constant k into x square minus the sum of roots into x plus the product of roots, means k into x square minus alpha plus beta into x plus alpha beta for some k not equal to 0. If it is a cubic polynomial, the required polynomial will be in the form of k into x cube minus alpha plus beta plus gamma, that is sum of roots into x square, plus alpha beta plus beta gamma plus gamma alpha into x, means the sum of product of roots minus the product of roots alpha beta gamma. where k is not equal to 0. To get a clear picture of the relationship between the zeros and coefficients of a polynomial, let us take some examples. The first one, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. A quadratic polynomial means it is of the form ax square plus bx plus c. In the first example, 6x square minus 7x minus 3. First of all, you factorize the polynomial, which will give you 2x minus 3 into 3x plus 1. That means when you equate it to 0, the value of x will be 3 by 2 or minus 1 by 3. It has two roots which are 3 by 2 or minus 1 by 3. Now, according to the relationship, the sum of zeros is given by minus b by a. Now, when you compare 6x square minus 7x minus 3 with ax square plus bx plus c, minus b by a will be minus of minus 7 by 6, which is 7 by 6. Also, you can verify that the sum of roots 3 by 2 plus minus 1 by 3 is also 7 by 6. Means we can say that the sum of roots is given by minus b by a. Similarly, product of roots is given by c by a, which is over here minus 3 by 6 or minus half. Again, the zeros or the roots which we have obtained are 3 by 2 and minus 1 by 3. When we multiply them, we again get minus half. So the product of zeros is always given by c by a. In the second case, the given polynomial is t square minus 15. By difference of 2 square, a square minus b square is equal to a minus b into e plus b. We get it equal to t minus root 15 into t plus root 15. So the zeros will be root 15 and minus root 15 by equating to 0. The sum of the zeros in this case will be root 15 plus minus root 15 is equal to 0. And according to our relationship, it will be minus b by a. We know that over here the coefficient of t is 0. So b is 0. So that will again be equal to 0. Product of zeros in this case is root 15 into minus root 15, which is equal to minus 15. And according to the relationship, it is equal to c by a, which is constant term upon coefficient of x square. So over here it is minus 15 upon 1 or minus 15. So in both the cases, sum of zeros and product of zeros, the relationship is satisfied. Second example, find a quadratic polynomial each with the given number as the sum and product of its zeros respectively. Now we know that the relationship is x square minus sum of zeros into x plus product of zeros. You can also have k into x square minus sum of zeros into x plus product of zeros. For simplicity, you can take k is equal to 1. So this is our required polynomial. Suppose if the sum and product are given as 0 and root 5, the required polynomial will be x square minus 0 into x plus root 5 or x square plus root 5. Suppose if sum of zeros is 1 by 4 and the product of zeros is minus 1, the polynomial will be x square minus 1 upon 4x minus 1, or you can also write it as 1 upon 4 into bracket 4x square minus x minus 4. Like we have the division rule for numbers, which is dividend is equal to divisor into quotient plus remainder, we have the division algorithm for polynomials. If px and gx are any two polynomials with gx not equal to 0, we can divide px by gx. Then we can find polynomials qx and rx such that px is equal to gx into qx plus rx. Qx is the quotient polynomial and rx is the remainder polynomial, where rx can either be 0 or the degree of rx is less than degree of gx. Next example, divide the polynomial px by gx and find the quotient and remainder, where px and gx are given. Now, as usual, we divide x raised to 4 minus 3x square plus 4x plus 5 by x square minus x plus 1. If I want x raised to 4 from x square, I have to multiply by x square. So the first term is x square. When gx is multiplied by x square, we get x raised to 4 minus x cube plus x square. We reverse the sign, subtract it, and we get the next term. Similarly, we carry on the division, and at last we get the remainder as 8. So over here, the quotient qx is x square plus x minus 3 and the remainder is rx. Next example, check whether the first polynomial is a factor of the second polynomial. Now this is like numbers. Suppose if I divide 6 by 2, 6 by 2 is 3, where remainder is 0. So I can say that 2 is a factor of 6. But if I divide 7 by 2, the remainder is 1. So if the remainder is not 0, I can say that it is not a factor. So in the first example, we are dividing 3x raised to 4 plus 5x cubed minus 7x square plus 2x plus 2 by x square plus 3x plus 1. Again, first term is 3x raised to 4. If I want 3x raised to 4 from x square, I have to multiply it by 3x square. So I get 3x raised to 4 plus 9x cubed plus 3x square. Reversing the sign, subtracting it, we get the next step. We carry on the division. At last we get the remainder as 0. So as the remainder is 0, we can say that x square plus 3x plus 1 is a factor of 3x raised to 4 plus 5x cubed minus 7x plus 2x plus 2. Now in the second case, we have x raised to 5 minus 4x cubed plus x square plus 3x plus 1. We divided by x cube minus 3x plus 1. Now after carrying on the division, we get the remainder as 2. Now since the remainder is not 0, we can say that x cube minus 3x plus 1 is not a factor of x raised to 5 minus 4x cube plus x square plus 3x plus 1. Now friends, currently the syllabus of class 10 is limited to quadratic polynomials, but the same rules can apply to cubic polynomials also. A simple example. Find a cubic polynomial with sum of product taken 2 at a time and the product of zeros as given 5, minus 3 and minus 7 respectively. Now we know what is the relationship between roots and the equation. So accordingly we can form the cubic polynomial. Here the three roots alpha plus beta plus gamma, the sum of the root is 5. The sum of the product of roots taken 2 at a time is minus 3 and the product of roots is minus 7. So the required polynomial will be any constant k into x cube minus 5x square minus 3x plus 7. Friends, hope you have understood the key concepts of polynomials. In the next video, we are going to solve all the important examples which will cover the entire chapter of polynomials. Please do like and share the video and do subscribe to my channel Maths Practice. Thank you.